So this is Dripping Springs, Texas. This is where I live. It's a small town located about 20 miles or so outside of Austin, Texas. It's a great place to live. And a good friend of mine is a skater. He teaches young kids skate class here in town. And for the last 2 or 3 years, he has been trying to press the city into starting a public skate park. And real quick, sidebar, that bar right there, I got kicked out of it about 6 months ago, standing up for my lovely bride's honor. Now I'm too embarrassed to go in there. Anyways, so yeah, he wants to build a skate park here in town, and the city has donated the land just a few weeks back, and now it's up to him to raise the money to actually build the park. And one of the ways we're going to do this is I'm going to build a bunch of fidget spinners out of recycled skateboard decks. And I'm going to do this with a CNC router provided by Next Wave Automation. It's a CNC Shark HD4. This is our stop sign. Here in a minute you'll see our stop light. We're all pretty proud of that. In any case, stay tuned and let's build some fidget spinners.
Wait, stop. This crazy bastard is Dennis Baldwin. He's the buddy I was telling you about that has been sort of leading the Dripping Springs skate park initiative. He has his own YouTube channel that I will link to in the description. He's also helping me figure out this fidget spinner thing and provided a ton of used old skateboard decks to use as materials for this project. So let's start with one of Dennis's old skate decks. The first step is to remove the grip tape from the top side of the board. This is probably the biggest pain in the ass in the whole process of making recycled skateboard fidget spinners. We tried chemicals, we tried brute force, we tried just about everything we could think of. The only thing that really worked was a heat gun and some good old elbow grease. So that in mind, if anyone out there has any better ideas, let me know in the Garage Journal. I'd be all ears. Anyway, once the grip tape and its residue was off the deck, I took it to the bandsaw and cut out the center of the board between the truck mounting holes. From there, I sanded off the finish of the board on both the top and bottom sides. This is pretty important because these surfaces will be glue surfaces eventually. With that done, I set up my table saw sled with a stop block to cut strips from the deck that were roughly 1/4 inches wide. Now, a typical skateboard deck isn't symmetrical or even perfectly straight along its rails, so you don't have to worry about accuracy here so much. I just did the best I could to keep the strips consistent. And once I had the strips cut, I moved on to the glue up. The clamping here is a little overly complicated, but I wanted to make sure my glue joints had good pressure, while at the same time, the sheet of laminated skateboard cross sections remained as flat as possible. I did this by placing a heavy old vise on top of the clamped up lamination. I then let the glue dry for a day or so and then took it all apart. It might be important here to mention that I placed the glue up on top of a piece of pre-finished plywood. The idea here is that the wood glue won't adhere all that well to the finish, and I'll be able to pop the lamination off once the glue up was finished. It wasn't as easy as I expected to pop the piece off the plywood, but eventually I got it loose and everything looked good. Now remember when I mentioned cutting those 1/4 inch strips from the skate deck and the lack of accuracy involved? It's time to deal with that sin. The ideal tool here would be a drum sander, but I don't have one. So instead, I just hand sanded the lamination smooth and got it as flat as my eye could detect. After sanding it down to 220, the final piece ended up being just a hair shy of 1/4 inch thick. I was pretty happy with that.
And now it's time for the CNC machine. This is a CNC Shark HD4 by Next Wave Automation. They didn't give us this machine, but they gave us a pretty steep discount to support the skate park, which was extremely cool of them. And after some shipping snafus, I just got it put together and set on this kind of temporary cart and wired up. I haven't used it yet. I have no idea what I'm doing. So I thought you guys could kind of follow me along as I learn. It comes with a piece of software called VCarve, which is what's pulled up on my desktop or on my laptop here. And I've already designed, what I did was I designed it in Adobe Illustrator, which is a software I know, and then I imported it into VCarve and followed a little tutorial to kind of set my depth, set my bit, that kind of thing. And now I'm simply going to save it from this software onto a memory stick
and then stick the memory stick into the CNC and we'll just see what happens. So hang on. The first thing you do before you run the code in the CNC that you created in the VCarve software is to set the X, Y, and Z axis zeros. Essentially, this matches your material on the CNC bed to the job site you created in VCarve. Once that is done, you basically just press go on the CNC and hope like hell you did everything right. When the machine is done throwing chips all over the place and you pull the piece off the bed, it sort of feels like magic. I still can't really believe that I assembled this machine, learned the basics of VCarve, and cut my first prototype spinner all in under an hour and a half or so. I mean, technology is amazing. And I continue to be amazed, because that CNC, man, it kind of opens up a whole new world of possibilities. I've played around a lot more with it now. I've done 3 or 4 different prototypes of the 2 different designs that Dennis and I came up with. The first one is a more traditional 4-bearing design with 1 main bearing in the center and then 3 on the outside for rotational mass. And I like it maybe even the most, but I'm a little concerned once we cut this out of the skateboard ply about strength on the edges of these outside bearings, as that material is pretty thin. And you can't really add a lot more material there because then it'll become too big to spin in little kids' hands. So I've come up with kind of an alternative that I'm going to cut out as well, which is a main bearing in the center and then brass plugs for the rotational mass on the outside. So those are my 2 designs. I'm going to cut them both using our laminated skateboard ply, and we'll see how it goes. I left the dust control off the CNC this time so you can see how this thing cuts. And I have a little more time using the machine now, and while pressing the go button is still a bit of a leap of faith, I just can't get over the capabilities of the HD4. In this pass, I cut out 3 spinners in a little over 45 seconds. And once the spinners were cut, I took them over to the bandsaw to cut the tabs off, freeing them from the ply. And then I just used the disc sander to clean up those cuts. At this point, the 4 bearing spinners are ready for finishing, but I needed to cut some brass rod to use as rotational mass on my alternative design. I put a metal blade on the bandsaw and got this done quickly. From there, I just pressed the brass rod into the spinner using a little CA glue for security, and then sanded the faces smooth. For some reason, these alternative spinners remind me a bit of a handcrafted pocket knife. The last step is simply spraying a finish on the whole thing to give it some shine as well as a little protection from the elements. I just used a spray-on polyurethane for my prototypes. Once the finish had dried, it was time to assemble everything. I designed the bearing reliefs to be very slightly oversized, so everything was a pretty snug press fit, but it went together pretty well. I even stole some bearing buttons from a couple of my son's spinners. They help with a smooth spin, plus they look cool. Thanks, Miller. And there you have it, a couple of prototype fidget spinners made out of recycled skateboards. My alternative design feels the best in the hand. It's really well balanced and incredibly smooth, but the brass just doesn't provide as much rotational mass as the bearings do, so it just doesn't spin as long as the traditional spinner does. Plus, the added labor of finishing those brass inserts probably makes this design infeasible. Obviously, we are still prototyping, but I'll be sure to let y'all know when these are available. All proceeds will go to funding the Dripping Springs skate park, and that's a pretty cool thing to support. Anyway, see y'all next time.
Oh my god, no! No!